gravitational wave. In 2019, the LIGO experiment detected a collision, GW190814. One object was a 23 solar mass black hole. The other, at 2.6 solar masses, is the problem. When massive stars die, they become either neutron stars, up to 2.5 solar masses, or black holes, starting around 5 solar masses. The space between is called the mass gap, where nothing should exist. And yet, this 2.6 solar mass object sits right in that forbidden zone. It could be the heaviest neutron star ever found, or the lightest black hole. Either answer breaks physics. A neutron star that heavy defies our equations for matter. A black hole that light defies our equations for stellar collapse. Either way, our textbooks are wrong. The universe just handed us a creature we've never seen before, and we don't even know what kingdom to put it in. Number 4. The Anita Anomaly. A NASA balloon over Antarctica, Anita, was designed to detect high-energy particles coming down from space. That's the only direction they should come from. But Anita detected particles shooting up out of the ice, not down, up, like someone underneath Antarctica was firing them at the sky. These were high-energy tau neutrinos, which shouldn't be able to travel through the entire Earth. The Earth is far too dense. It should have absorbed them. It's like trying to fire a bullet through a mountain the size of a planet, but it came out the other side, like the Earth wasn't even there. Scientists checked the equipment and data repeatedly. Everything was normal. One explanation that fits the math is a parallel universe where time runs backward. In that universe, these particles would be traveling normally, but from our perspective, they'd appear to be doing the impossible, moving the wrong way, from the wrong direction, breaking rules that don't apply to them because they're not from here. Scientists are still desperately looking for a boring explanation, but they haven't found one yet. Number 3. The galaxy with no dark matter. Dark matter is the invisible scaffolding of the universe. Its gravity is thought to be a non-negotiable ingredient for holding galaxies together. So when astronomers found galaxy NGC 1052 DF2, they were stunned. It has billions of stars but essentially no dark matter. It's like finding a person walking around with no skeleton. It should have collapsed. It shouldn't exist. The stars inside move slowly, confirming the absence of dark matter's gravity. The galaxy is perfectly stable without the one ingredient we thought was essential. This discovery was so shocking. Some scientists argued maybe dark matter doesn't exist at all, and our theory of gravity is wrong. The leading theory is that the galaxy was mugged by a larger neighbor, which stripped away its dark matter. This raises a weirder question. If a galaxy can survive without dark matter, what was it doing in the first place? We've since found more of these ghost galaxies, and even their opposite, galaxies made of almost nothing but dark matter. The universe is experimenting with its own recipes without telling us the rules. Number 2. The impossible galaxy. The James Webb Space Telescope was imaging the early universe when it found something that made scientists do a double take. A massive, fully formed galaxy, sitting where only infant galaxies should exist. It existed when the universe was just 700 million years old. A cosmic infant. Galaxies need billions of years to form through a slow, messy process of gas clumping and star birth. They do not just appear overnight. This is like finding a fully grown adult sitting in a hospital nursery, wearing a suit and reading a newspaper. Scientists called it the impossible galaxy. Its official name is ZFUDS 7329. Its stars are old, cool, and red, not the young, hot blue stars expected in a baby galaxy. They had already lived long lives. This means the stars started forming even before the galaxy looks like it should exist. It's like finding a grandfather inside a baby. Our leading model of galaxy formation, Lambda CDM, has no explanation. It cannot account for something so massive forming so fast. It's as if the early universe was running on fast forward, and nobody told physics. Number 1. A neutron star too massive to exist. Imagine a 15-ton truck crossing a bridge with a 10-ton limit. The bridge should collapse, but it doesn't. That's what's happening with a specific neutron star. Neutron stars are city-sized objects weighing more than our sun. A single teaspoon would weigh 1 billion tons, but physics has a hard mass limit for them, the Tolman-Oppenheimer-Volkoff limit. Beyond it, gravity should be so overwhelming that the star must collapse into a black hole. That's the rule. NASA found a neutron star sitting comfortably above that limit. It hasn't collapsed. It's just sitting there, being too massive, and not caring, all while spinning hundreds of times per second. This matters. Either our understanding of the limit is wrong, or some new, unknown physics is happening inside that star, a new force holding it up against collapse. This limit wasn't a guess. It was calculated from our best understanding of matter under extreme pressure. If that calculation is wrong, other physics built upon it might be wrong too, like a crack in a building's foundation. Number